Okay, let's get started. Welcome to this talk. Thank you very much for choosing to join us today. I'm very excited to show you some of the great new stuff that we've been working on in Blazor WebAssembly for .NET 6. My name's Steve and I work at Microsoft on the Blazor and ASP.NET Core teams. So of course I'm very pleased that we've got some great new stuff for you in this release. So to set your expectations for this talk, we will mostly be focused on the new WebAssembly specific features for Blazor in .NET 6. There are other talks that will tell you about other Blazor features, but we'll mostly think about WebAssembly. And hopefully I'll inspire you with some ideas for new kinds of app capabilities that you could create now that you wouldn't have done before. And as we go, we'll certainly think about some of the impressive performance improvements that are being brought in this new release. So to do all this, we're going to need a scenario to build an application around as some examples. Okay, now I don't just want a basic hello world kind of thing. I want to think about an ambitious business with lots of different parts and different technologies. So I thought, since I'm a billionaire, and like most billionaires, I should have a space agency, that I would just set one up. So I've created a space agency that I call Blazor WebAssembly. And I would like you to come and work at my space agency as one of the top software architects. And to do that, you will of course need to know a bit about the business and the technologies that we use. So I'll tell you about it, okay? So we've got this group of central servers and databases, and they deal with storing all the important business data and the authentication and everything like that. Okay, and that's all implemented with ASP.NET Core, but you won't need to work with that too much. You'll mostly be focused on a front end. This part of the business is called the manufacturing group, and they're responsible for designing and building rockets and managing warehouses and things like that. And they've got a front end implemented in Blazor WebAssembly. It's an existing application. Okay, now there's another part of the business called the missions team. They deal with people who are actually in space and tracking the movement of satellites and things like that. And they've got a front end implemented with React. It's just a different team. They've made a different technology choice. Okay, and then there's a third part of the business called accounting. And you probably want to get paid, right? So you will want them to have functioning systems. And they've got an existing application that's built with WPF. It's a native Windows desktop app. It's a bit legacy, but you know, every business has these kinds of things. You'll need to work with that a bit as well. Okay, now I almost forgot, there's one other group, and these are the people who create shared libraries that other teams in the company can use, and they insist on using only Rust, whether or not that's convenient to you. Okay, so let's imagine that you take this job and you're working on the Blazor WebAssembly manufacturing hub. Let's say you're using .NET 5 and you've been doing it for a while and it's going well, you like it, you're having a good time. But one day I come to you and I say, hey, I've got some new requirements for you. We're having a bit of trouble with our warehouses and tracking all our stock. I need you to build a new inventory management system. So please take some notes. Here are the feature requirements. It needs some very fast and powerful querying so people can rapidly cross-reference where everything is. But you're not allowed to put any new heavy load on the server, okay? Because they're busy enough as they are. Thirdly, this is a space agency. We've got to be fault tolerant. Networks can go down during missions, and we need your new feature to keep working regardless, including the querying. Okay, and it's not quite enough to only add this into the Blazor application. It also needs to go into the React and the WPF applications too for business reasons. I know they're on different technologies, but just figure it out and make it work somehow or other, will you please? And then finally, there's a need to print out stock labels with QR codes, and the Rust team has already created a library for that. So please use that library that they've created in your application. I don't know how you're going to use Rust, but just do it one way or another. Okay, right. So that's kind of a complex set of requirements, but maybe there are some new features in Blazor WebAssembly on .NET 6 that will help us out. So let's try it, shall we? Now, I'm going to switch over to my code editor and I'll show you the existing manufacturing hub application. Okay, now of course it's secured. We need to log in order to speak to the secured gRPC endpoint, so I'll do that. And when I'm logged in, I'll be able to access this data on the central servers about what's going on in the warehouses. But we don't really care about that right now. What we care about is this inventory screen. Now, if we're going to do powerful queries without having to bother the server, and if we're going to have to be able to run offline, we're going to need an in-browser database. And wouldn't it be nice if we could use the industry standard embedded database, Sqlite, as well as .NET's leading tool for working with databases, Entity Framework Core. Now that was not possible in .NET 5 and earlier, and I will show you why. I'll show you what goes wrong if you try. So I've got a bit of code already, which is going to create a database context, an EF Core DB context, and say that I want it to use Sqlite. Okay, and then there's a bit more code that tries to create a DB context. It will insert a new row into it, and then it will try to query it back. But does it work? Let's find out. If I click this try it button, what happens is we get an unhandled error. Okay, why is that? What's the error? We'll look in the console and we will see that the underlying problem here is that we were not able to load this DLL called eSqlite 3. Which makes sense because it's WebAssembly. You can't just load random DLLs into it. And so for .NET 5 and earlier, that was just the end of the road. You couldn't do this. Okay, but with .NET 6, we've added a pretty important new feature called native dependencies. And that gives you the ability to compile other code to WebAssembly and link it in to your application. So how about we try to use Sqlite? So I need to compile it to WebAssembly. So I've got a command prompt here. And if we look in there, you will see that I've got the Sqlite 3 source code, and I am going to compile that to WebAssembly as a shared library using the mscripton C compiler. Okay, the warnings are bogus, you can ignore those. And when I've done that compilation, I can now link it to my application. So I'm going to go to my project file, and down here, just near to where I've referenced the Sqlite package, this is the Entity Framework package, I will add the new thing. And the new thing is a native file reference to the eSqlite 3 thing that we just compiled. Okay, so when you've done that, the next time you compile, you'll find it takes slightly longer to build, just the next time that is, because it realizes that things have changed and it has to rebuild the WebAssembly binary and relink it with the thing that you just added. When that finishes, hopefully it will reload inside the browser. So here it comes, reloading. And when it comes back up, I will try doing the same thing as before. And do we get an error this time? We do not. There's no errors. It's actually working. It's successfully running Sqlite inside our WebAssembly application and using EF Core in there, which is a whole new thing that you wouldn't have done with .NET 5. And that creates some powerful new opportunities for you to do some new things with data inside the browser that you wouldn't have done before. So let's imagine that you do another couple of days of work and you create some code that will fetch data from the back end and it will synchronize it with this client-side Sqlite database, and we'll start building a grid to show that data as well. So let me just jump forwards in time to the next version of our inventory component where we're going to do some of that stuff already. Now, we will need to rebuild that, and we will get some hot reload going in a minute, but I just pasted in way too much code to be hot reloaded. When that comes back up, you'll see it's now doing something quite a bit more interesting. It's fetching this data from the backend server and it's showing it in a grid. We can even start working with it before it's synchronized. But how is this actually working? Well, I made this little component called Data Synchronizer that fetches stuff from the server. And then I've also got this sync status component that's displaying the progress bar. Okay. Now the other code down here is pretty basic. It's just getting an EF Core DB context, and then we're starting on making a little grid for it. And you can find all the code for all of this on GitHub. I'll give you the link at the end of the talk. Okay. Let's have a go at working with this grid a little bit. All right, so I'm going to move this over here a little bit and resize my window slightly. Okay, now first thing I want to notice is that I can do things like change the sort order, I can scroll anywhere I want very rapidly. Even though there's 100,000 items in this list, I can just instantly jump to any part of it because it's a virtualized UI. It's very fast and nice to work with. Also, I can change the code. Let's see if we can do some hot reloaded code changes here. So let's say that these price in cents, I want to format it as currency like that. I'm going to press save, and then we'll see instantly in the browser we retain the sort order and scroll position, and now it's using currency formatting. But it's actually wrong because it says British pounds, but I'm going to pretend that these are dollars. So let's change this like that, and now we get a dollar sign, but that's in cents, so I need to divide it by 100. That's a bit better, and I want to have a comma separator, so I'm going to say to string numeric with 0 decimal places. That's looking pretty good. But I don't really want to repeat these dollar signs in every single line, so let's get rid of that from here, and I'm going to put it into the title up there. That's pretty good, and because it's a number, I want it to be right aligned. Okay, so that's pretty nice, and it's a pretty super experience to be doing that with hot reload. We can probably do some more stuff as well. Let's say I want to change the order of the columns. I'm going to put name first. That's very quick. Maybe instead of displaying ID, that's kind of useless, I'll display the in stock level like this. Stock like that. Okay, cool. That's pretty good. What else could we do? Well, we could add as much functionality to this as we like. So let's imagine that you do another day or two of work on your application, and you add a little bit of code that deals with filtering as well. So again, I'm going to jump forwards to a newer version of this where we pretend that we've done a little bit of work to support some additional filtering stuff. Okay, so that's going to reload in the browser, and now you'll see there's quite a bit more stuff going on. There's more columns. I've now got things like this ability to multi-select categories and subcategories. That's using another new Blazor feature for multi-selected data binding. Then let's say, we'll come back to that in a minute. I can also do things like searching. Let's search for this Polterdine stuff. You can see that updates in real time as I type. Again, I can still change sort orders, obviously. And here's a more interesting one. Watch what happens when I move these sliders. Look at the number in the bottom left where it says showing 100,000 items. As I move this minimum stock level, can you see how that's updating in real time? I don't know how smoothly that comes across to you, but it's absolutely perfectly smooth for me. And it's a pretty amazing user experience to be able to do this kind of real-time querying. You basically don't normally see this on the web because it's kind of hard to do this, especially if you're querying a server every time. But when you've got a local database, you've got EF Core, and you've got virtualized UI from Blazor, this sort of thing just kind of all comes together, and it's a pretty magnificent experience for the end user. So this is all very cool. So let's think about where we are on our journey to satisfying the CEO. Okay, so we've implemented some fast, powerful querying, and it doesn't involve any heavy server load because even when we do this real-time filtering, it's just using a local single user database. Now, what else do we need to think about? What about this QR code thing? Okay, so if I go back in here and I pick something, let's have this, I don't know, nose connector, whatever that is. You see this gray box here. Well, this is where we want to add a QR code so that people in the warehouse can print it out. And that's already been implemented in Rust, but how do we consume Rust code in a Blazor WebAssembly application? Well, with .NET 5 and before, you just wouldn't do, but with 6, again, we can use the native dependency feature to reference a Rust library. I've created a Rust library and compiled it to WebAssembly using the standard Rust toolchain. And again, you can see the code for this after the talk if you want to. But if I want to use it, all I have to do is add another native reference. And in fact, I've already added it. So let's see the code for our QR code component. Let's move this across here and pick something again. That's kind of difficult to see. So I'll just zoom out a bit. All right. So this is a slightly more low-level kind of native dependency because this time I've created a DLL import method. This is the thing that's been exported from the Rust library that takes the value for the QR code and fills up a buffer with that data, and then I'm going to display it in a canvas element. So if I change this to call the Rust library, then as soon as I do that, the hot reload kicks in and we now see a real QR code showing up here in the browser, which actually works. And again, you can see the code for that later if you want to. All right, so we've been able to use the Rust library. Next thing, what about making it work offline? Well, in a sense, we don't really have to do any work to make that happen because Blazor has always supported offline enabled PWAs with WebAssembly, and we've got a local database, so it's kind of just going to work. Let's try it to actually verify this for ourselves. And to prove that we can work offline, I am going to shut down the web server that this uses. If I can find my command prompt, here it is. Right, so I've shut down the web server completely. And when I start up this PWA that I published earlier, you'll see it looks and behaves the same as normal. It takes a little longer to start because it's trying to talk to the server and it realizes that it can't. So we can't see any dashboard data. But if I go to the inventory screen, we've still got all the data that we had locally from earlier. And we can still do the same filtering and so on that we did before in real time. But we know we can't talk to the server, so we can provide a UI around that. All right, so that was pretty easy. We didn't really have to do anything to make that work. Okay, so that's pretty good. Time for a little bit more of a challenge though. How are we going to put this into the React and WPF applications, given that they're implemented with other technologies? Well, let's start with the mission control application, shall we? I've got a VS Code window over here, which is running this React application. I'm just going to start it up in my browser firstly. Okay, so this is the mission control application where we track the satellites and we count how long it's been since we've seen any aliens and so on. Of course, it needs to support authentication as well. So I'm going to have to log in with the same account that I had before. Okay, that's using the single sign-in, so I'm logged in. And what we really want to focus on now is implementing this equipment finder. Okay, this is where we want to use the inventory grid that we just created in Blazor WebAssembly, but now we want to use the same thing in a React application. How can we do that? Well, let's find the source code for that React component, shall we? It's this one here. It's called equipmentfinder.js. If you don't know React, this might look a little bit unfamiliar to you, but don't worry about it. All we're doing here is keeping track of some text that's been entered into a search box up here, and then we want to add some more stuff at the bottom. So let's reorganize this a little bit so we can see a bit more stuff like that. Okay, cool. Right, so how would we add the inventory grid? Well, one way we could do it is we could just add an iframe and display the Blazor application in it. But that would be kind of rubbish because it would be like a separate application. It wouldn't share the same authentication state. It wouldn't share the same styling. It wouldn't be easy to pass parameters in and get them out and so on. Wouldn't it be a lot better if we could somehow just add the Blazor component as if it was an HTML element, like a web component? Well, that is another new feature of Blazor WebAssembly in .NET 6, and I'll show you how it works. So in our Blazor application, if we want to export something as a component that can be consumed from outside, we can do so in our program CS. And in fact, I've already done it. So here, I'm saying that I want to register a custom element, and I'm calling it inventory grid, and that will be the actual inventory component that we've been working on all along. So this actual extension method here is a preview feature, but the underlying infrastructure that makes it work is something that's actually shipped in .NET 6. So anyway, now I've done this and I've added a script tag to my React application to load the Blazor code. Let's see if it works. So I'm going to reference inventory grid here inside my React application. And when I press save, hopefully the hot reload system for React will kick in and it will add our grid that comes directly from Blazor. And it's got all the same functionality as before. It's working great, but not quite yet, because if I start typing in the search box, you'll see it doesn't do anything. And that's because I haven't passed the search into the search value as a parameter. So I'm going to say the search name that we're passing in is equal to the search text from React. And then I'll press save and you'll see immediately hot reload happens again and it's applied my query. And now as I type in real time, it will update in the UI. So that's good. Now, another cool thing, because this is an actual component and not an iframe, I can change the styling using React. So let's say everything else in this React application uses a dark mode. I would like a dark mode for the grid as well. So I'm going to go into the CSS for this thing here, and I can say inventory grid table. So we'll find the table in the inventory grid, and we'll apply a filter to say I want to invert it. And immediately we've got a nice dark mode going on. All right. Now, finally, what about hot reload? If I've got some state in my React application and I change something here, so if I say super equipment finder, you'll see, of course, it changes that state while preserving everything else. That's good. And it's even preserved the state of my .NET application. And if I change my .NET code as well, for example, I'm going to go here to the, let's change this category title here to be cat name, just for the sake of making a change. And I'll press save. And then back in the browser, you'll see immediately the .NET hot reload kicks in as well. So we can do .NET hot reload and preserve the state of both the .NET and React code. And we can do React hot reload to preserve the state of both the React and the .NET code. So both hot reload systems are working together, and you can be super productive, and I can give you a promotion as a result. So well done to you. All right. Now, last one we need to think about is this WPF application. Now, that's adding Blazor components to a native desktop application is not something that's shipped in .NET 6, but it's something that we are adding with the Maui release next year. And I'm going to show you how that might look right now very quickly. We won't focus on it too much. I've got the accounting project here, which is a WPF application, as I mentioned before. And when I compile that and start it up, hopefully that will come up around now. Oh, there it is. Right, good. Okay, so we don't care about all this existing stuff. We just care about this inventory tab. And I just want to prove to you that we can embed our Blazor component in there and make it integrate with things like auth as well. So of course I have to log in, otherwise we couldn't talk to the back end. But when we've done, our exact same code as before will just start working and have all the same capabilities as before. It really is the code that we just implemented with the cat name thing, and it all works the same as before. But I don't have time to really talk too much about how that works. So what I'm going to do is move on from that, and we'll talk about something else. Okay. So we've satisfied all those requirements, which is brilliant, but we haven't talked much about performance yet. Okay, one of the other big features for Blazor WebAssembly in .NET 6 is ahead of time compilation. And that means that instead of running your code on a .NET interpreter inside the browser, it can be pre-compiled to native WebAssembly bytecode and run much faster. So to quantify that, let's consider a different example. Okay, let's imagine that our scientists have been creating a simulation of satellites in a binary star system. Okay, sounds cool, is actually kind of basic, but I'm just going to run that now. It's a very, very simplistic physics model here, but it is implemented in .NET, and you can see the code of it if you want. It's only about 80 lines of code. So that's simulating these satellites moving around in a binary star system. And the question I'm interested in is, how many can we simulate before we start dropping below 60 frames per second? We've got 100. Can we manage 500? Yes, we can. What about 1,000? No problem. 2,000? Sure. 4,000? Yep, still 60 frames per second. 5,000 maybe? It kind of dropped a bit maybe there, I'm not sure. 6,000? And still kind of going-ish, maybe 7,000. Oh, and it's now well below 60 frames per second. So this is not AOT compiled code. This is running on the interpreter, which is, fairly fast. But how fast could we get it if we ran in AOT? So I've published this application with ahead of time compilation already, and I'm going to start it up and we'll compare the speed to what we had before. Okay, so we know we should be able to manage 100, 1,000, 5,000. Of course we should, because we did that on the interpreter. What about 10,000? Yep, that's still working fine now. 20,000? Yep, still 60 frames a second. How about 40,000? Again, yes, still working. 50,000. Yep, still 60 frames a second. 70,000 maybe? No, it's dropped off now. But we've had more than a 10 times speed increase compared with the speed of the interpreter there. Okay, so to really nail this down, I'm going to give you some numbers on graphs. Okay, so when I tested this earlier today, I measured 4,500 satellites that we could manage in debug build. When I did a release compilation, it more than doubled, which is great. That's still on the interpreter. We were getting 12,000 satellites then. But with the AOT build, we got a whopping 58,000 satellites there. And you will generally see these kinds of massive speed ups when your code is CPU bound. Okay, so AOT compilation can have some phenomenal speed benefits for your application, but it does come at a cost. And I want to communicate the cost to you as well, because I'm all about giving you a realistic picture and not just making it look better than it actually is. Okay, so the realistic situation for application sizes on Blazor WebAssembly in .NET 6. First, let's imagine that you're building a very small application, such as this satellite simulator. It doesn't do very much. When you publish this, you will find that a release build of it is 1.1 megabytes. Now that is an amazing improvement compared with .NET 5, because the smallest Blazor WebAssembly app on .NET 5 was 1.7 megabytes. What we've done is added the ability to strip out a lot more code, and that's how that gets to be so small. However, if you AOT compile it, it will go up to 2.8 megabytes. So it's more than doubled. And in this case, it's probably really worth it for that speed gain. But of course, it is quite a bit bigger. Now, as for the default application that you get when you do a file new project, on .NET 6, that's 2 megabytes. It's slightly down from .NET 5. But, you know, it's still not that much smaller because we haven't stripped out loads of stuff by default because we assume you're trying to use it. If you do an AOT build of that, it will come in at 4 megabytes. So it is doubled there. It's faster, but it's bigger. And then finally, I want you to think about a really big application because, you know, people do build really big applications as well. And it's important to be realistic about these things. So if you've got some very big, heavy dependencies, then your application itself will be big and heavy. There's no way around it. And an example of that is Manufacturing Hub, because that uses EF Core, which is not designed for code stripping in any way. We might do some optimizations like that in .NET 7, but for .NET 6, if you depend on EF Core, your app's going to be pretty big, okay? So that one is 5.5 megabytes. And if we AOT compile it, it comes in at an enormous 15 megabytes. Now, in this case, I would not AOT compile that application because all the heavy lifting is happening inside Sqlite anyway. The .NET code doesn't really even break a sweat, so there's not really any point AOT compiling it. But in the case of Satellite Simulator, I definitely would. So it's up to you to decide for your application whether the trade-off is a good one. All right, so that's all I'm going to have time to talk to you about today. We've talked about AOT compilation. We've talked about adding native dependencies with Sqlite in our example and the Rust code. We've also looked at the dynamic root components feature. That's the thing that allowed us to add the component to a React application. It would also work just the same with Angular, Vue, or any just plain HTML file because it's a web component and you could use it anywhere. We've talked a bit about how production apps can become much smaller if you enable all of the code stripping features. We've looked at quite a few examples of hot reload through this talk. And one thing I didn't mention actually is the custom bundling feature that allows you to control the shape of the published output. You can read docs if you want to see more about that. So thank you very much for listening to this talk. If you want to see the source code and try it for yourself for all these demos, you can find it on GitHub at the URL that I've put up on the screen there. And that's all I have time for. So thank you very much. And I hope you enjoy the rest of the conference.